Okay, we're going over lesson 37, unit 7-1, page 427, basic trigonometric identities. We're going to learn some basic identities, and what it's going to do is allow us to manipulate trigonometric equations. We already know how to manipulate equations using addition, subtraction, multiplication, and division, and their inverses. But what we're going to do here is learn to manipulate by substitution. We're going to learn that this one thing is equivalent to something else. When we first began that, we were solving systems of linear equations by substitution. And we'd say, like, if y equaled 2x plus 6, we could replace y with 2x plus 6 and make our equation simpler to solve. We're going to be doing substitutions like that, but we're going to be doing it with trigonometric identities to simplify trigonometric expressions and try to get ourselves closer to be able to understand the situation. Okay? The reciprocal identities we've already learned. We know that the reciprocal of sine is what? The reciprocal of sine is cosecant. So the reciprocal of sine theta is equal to cosecant theta, and so we would write it like this. We would say that 1 over sine theta is equal to cosecant theta. That's something we learned a long time ago. We learned that the reciprocal of cosine is secant, so we could say it like this: 1 over cosine theta is equal to secant theta. We learned that the reciprocal of tangent is cotangent, so we could say that 1 over tangent theta is equal to cotangent theta. So cosecant is reciprocal of sine, secant is reciprocal of cosine, and cotangent is reciprocal of tangent. So we know those to be facts already. Quotient identities or ratio identities, we learned this already. We learned that tangent of theta is equal to sine over cosine. Now, we barely talked about that. Let me explain to you how we kind of know that. Maybe we haven't done a whole lot of in-depth. So I'm going to come off to a tangent over here and show you something. When we did the unit circle, if you recall, we said that if we have a unit circle where this is 1, then what we have here is that this distance is x and this distance is y. And if we're talking about this angle theta, then we could say that the sine of that angle is equal to the length of the leg opposite y over the hypotenuse, which is r. So we said sine theta is y over r. We said the cosine of that angle theta is the length of the leg adjacent x over the hypotenuse r. And we said the tangent of that angle theta is equal to the length of the leg opposite y over the length of the leg adjacent x. Now here's why this quotient ratio works. If sine is y over r and cosine is x over r, dividing by a fraction is the same as multiplying by the reciprocal, so I could multiply by r over x and those would cancel. So if I were to take sine of theta, which is y over r, divided by cosine theta, which is x over r, by multiplying by the reciprocal r over x, the r's cancel and we get y over x, which is tangent, which mathematically proves that tangent is sine over cosine. Okay? We still need to remember for this particular lesson that sine is y over r, cosine is x over r, and tangent is y over x. That needs to be committed to memory. We're going to use that in lesson 37 and 38. Now, the reciprocal of tangent is cotangent. Therefore, cotangent is the reciprocal of sine over cosine, which is cosine over sine. We call those the ratio identities. Tangent theta is sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. Notice what we have is a toolbox full of things to substitute with. Way back in Algebra 1, we'd have two equations. One might be in standard form, one might be in slope-intercept form. We'd take the one in slope-intercept form, y equal this x junk, and we'd put that in place of x. We only had one thing to substitute with. The thing about trigonometry is you've got a whole toolbox, this whole double-sided sheet of paper full of stuff to choose from to substitute with, and you got to try to figure out which choice is going to get you where you're going the fastest. That makes it kind of hard. Even with your toolbox full of tools, it's still hard to figure out which one to use and how to use it. Okay? I don't know how else to explain that. You'll figure that out pretty quick anyway. All right. So we've got the reciprocal identities. We have the Pythagorean identities. We've got this little review down here that you can't forget because it's a part of your notes. That sine is y over r. Cosine is x over r. Tangent is y over x. And if we did the Pythagorean theorem, we would have x squared plus y squared equal radius squared, right? So if we knew two of those things, we could find the other one of those things by using the Pythagorean theorem. Now, the Pythagorean identities, the most common popular form of the Pythagorean identities is sine square theta plus cosine square theta is equal to 1. Now, we can figure that out pretty easy because we know in this unit circle that x is actually sine theta, or sine, I'll just call it theta. And we know that y, excuse me, I did that right. I did that wrong, excuse me. We know that x is really cosine theta, excuse me. And we know that y is really sine theta. And we know that this is the radius. And that in the unit circle, the radius is 1. Can you see the Pythagorean theorem in that? Sine square plus cosine square equal radius 1 square. It's the Pythagorean theorem with the most basic form of the unit circle, where the x move is cosine theta, the y move is sine theta, and the hypotenuse is 1, the radius of the unit circle. And so we have a squared plus b squared equals c squared, or x squared plus y squared equals radius squared, or sine squared plus cosine squared equal 1. Okay? But still we got that. That's pretty handy. If you can take some big drawn out mess like that, this equation that's got this in it, and you can replace that with a little bitty number like 1, that's a whole lot of simplifying fast. So that's a handy one to use to substitute with. Now the thing is we could manipulate that, right? If we were to move cosine to both sides, what would that look like? It would look like sine square theta equal what? 1 minus cosine square theta. That's what it would look like if we moved the cosine square to the other side, right? Remember to change the sign when you cross over? So we're going to have variations of these Pythagorean identities. Okay? So there's our first Pythagorean identity. Sine square plus cosine square is equal to 1. I'm going to make room for the other ones. We have 1 plus tangent square is equal to secant square. 1 plus tangent square theta is equal to secant square theta. And we have 1 plus cotangent square theta is equal to cosecant square theta. Okay? And some of these, most of these, I have committed to memory, and some of them I don't. And so I will need to do a little more study myself to get this totally committed to memory. The one in yellow we'll use more often than the others, but we'll use the others. All right. Now, if you go into the textbook and if you look at page 426, you might take a peek at that, page 426. It talks about opposite angle identities. Opposite angle identities. And it says that sine negative A, it says that sine negative A is equal to negative sine A, and it says that cosine negative A is equal to cosine A. Okay? Sine negative A is equal to negative sine A, and cosine negative A is equal to cosine A. Now, I want you to look at that for just a moment, because I need you to explain to me why that's true. Now, to explain why it's true, you got to think about it for just a second. While you're thinking about it, I'm going to draw our graph, and you got to think about it from a graphical representation. What does sine negative A mean? What does sine negative A mean? It means you go clockwise. That's all it means. What does sine A mean? Counterclockwise. That's normal. Now, remember our A Smart Trig class? A Smart Trig class. The sine of negative some angle A, is it the same as positive that angle A? No, because if you do positive sine A, you're in quadrant 1 where sine is positive. But if you do negative sine A, or sine negative A, you're in quadrant 4 where sine is negative. So if you do sine of negative an angle, it's saying if you go counterclockwise with sine A, where A is an acute angle, you're going to have a reference angle in quadrant 4 where sine is negative. So the sine of negative A is the negative sine of A. It's the opposite sign of what it would have been had it been sine A. Okay? But let's think about cosine. If we think cosine negative A, it's the same scenario. Cosine negative A is just going clockwise. It just means we end up in quadrant 4. Is the cosine of the angle in quadrant 4 the same as it would have been had it landed in quadrant 1? Yes, because cosine is positive both places. So cosine negative A is the same value as cosine A because cosine is positive in both quadrants 1 and 4. That's the opposite angle identities. So sine negative A is the negative of what it would have been had it been sine A. The cosine of negative A is exactly the same as it would have been had it been cosine A. It all has to do with what's positive in what quadrant. Any questions on that? Okay, so there's our identities, and what we want to do now is go to the worksheet and look at the lesson 37 things. And I'm going to try to leave all that on the board that I can, and us just kind of deal with these questions one at a time. And again, I encourage you to go to the book and read it and look at the examples, because there's more for you to get out of this than what I'm fixing to do on the board. And as you try to do your homework and get stuck, we'll try to deal with some more stuff. I know. Number 1, we have secant theta over tangent theta is equal to sine theta. Now, this isn't totally manipulating using these identities. What it asks us to do is prove that each is not a trigonometric identity. In other words, prove that that's not true. Now, to not be true, we only need one counterexample, right? There may be 1,000 counterexamples, but if we can find one example that makes it not true, we prove it's not an identity. All right? So you can come up with anything you want. Well, if we're going to deal with sine, cosine, tangent, we kind of like our quadrantal angles. Aren't those the easiest ones to mess with because they're 0, 1, -1, and undefined? So if we just throw in pi, for instance, then we would have secant pi over tangent pi is equal to sine pi. We're just trying to plug something in and prove it's not true. You could plug anything in. Why plug in something that's going to give you square root 3 over 2? Plug in something that's going to give you ones and zeros, something easy to deal with. You see, quadrantal angles are the best choices. Now, secant is the reciprocal of what? It's the reciprocal of cosine. Remember, secant is reciprocal of cosine. And what's the cosine of pi? Cosine pi, -1. Sine of pi, sine of 0 is 1. If you go to pi, you -1, right? And so it'd be the reciprocal of that, which would be -1. Now, what's the tangent of pi? What's the tangent of 0? 0. If you go over to pi, it's the negative of 0, which is still 0. What is the sine of pi? The sine of pi, the sine of 0 is 0. It's the negative of 0, which is 0. So we got our stuff plugged in. If you don't have any of your stuff memorized, you're feeling pretty miserable right now. You need to do your memory work, or you're not going to have a clue what we're talking about. What is -1 divided by 0? Undefined. Undefined is not equal to 0, and so we've proved it's not an identity because we found a counterexample. That's all we got to do. Find something to plug in, get all your stuff. You found out it wasn't equal, proves it's not an identity. Again, some of you know your unit circle memory work, and some of you don't. And the ones of you that don't, it's just going to get worse instead of better. Even if you have a calculator, you're still going to have trouble because you can't think through it fast enough. It's like trying to do fractions when you don't know your multiplication tables. It just kind of messes up your learning fractions a little bit. Any questions on number 1? Okay, number 2. Okay, number 2, we have sine x plus cosine x is equal to 1. Now we know there's a Pythagorean identity that says sine squared plus cosine squared equal 1, but this is not it. So we're going to plug in anything. You can plug in 0, pi, pi over 2. Pi is always kind of an easy one. I don't know if you like that better. You might like 0 better. Let's just do 0. Maybe you like that better. We had a little trouble with pi. Let's deal with 0. The sine of 0 plus the cosine of 0 is equal to 1. What's the sine of 0? 0. What's the cosine of 0? 1. Is that equal to 1? Yes. Does that prove it's true? No. It has to be true every time, not just once. If we can find one counterexample, it might be true. So I thought, well, let's find something easy. But that doesn't necessarily mean it's an identity. We're trying to prove it's not one, which means it must not be one. That or we're going to spend a long time trying to figure out it's not. When it is, that would be kind of mean for a test. Anyway, so let's throw something else in. Let's go back to, let's use pi over 2. So let's do sine pi over 2 plus cosine pi over 2 equals 0, equal 1, excuse me. Now, obviously, I'm doing some things on purpose here to cause us some problems, but that's part of the lesson. So what is the sine of pi over 2? 1. What's the cosine of pi over 2? 0. It still came out, so we were like, well, maybe it is an identity. But it's not. So there was a couple of things that didn't work for us. Let's find something that will prove it's not an identity. Okay, do what? So we could do negative pi over 2, or we could do 3 pi over 2, right? So let's do 3 pi over 2. Sine 3 pi over 2 plus cosine 3 pi over 2 equal 1. Now, if you know your unit circle stuff, we could have known we were going to be wrong, right? It wasn't going to work pretty fast a while ago, right? Because we could have done that in our head. But I've got to show you what goes through your head. Now, what's the sine of 3 pi over 2? Negative 1. Because it's the opposite sign of pi over 2, right? And what's the cosine of 3 pi over 2? 0. This time we get negative 1 is equal to positive 1, which proves that it's not an identity because it didn't work every single time. So when you do this on the test, Stephen, you may start doing it and you may say, well, it is an identity. No, it's trying to tell you it's not one. Keep trying until you find something that doesn't work, right? We want to find a counterexample. Any questions on 1 and 2? Proving that things are not identities. So if it's an identity, it means it's true every single time. It's true every single time. Yes. Yes. So for 1 and 2, everybody could have a different answer and it'd be right. There's more than one counterexample for every one of those, right? That is correct. All right. Question number 3. Question number 3, we have sine theta is equal to 2/5, where 0 degrees is less than theta is less than 90 degrees. And we want to find the cosecant of theta. We want to find cosecant theta. Now, what does it mean 0 is less than theta is less than 90? What'd they tell us that for? All they're doing is telling us what quadrant it's in. It's in quadrant 1, which tells us what's positive, and they're all positive. That way we know to make the final answer either positive or make the final answer negative. Now we know since it's in quadrant 1, the final answer is going to be positive no matter what they ask us for. Now we get to cosecant. Cosecant is reciprocal, of sine. Well, if sine is 2 over 5, and cosecant is the reciprocal of that, then it's 5 over 2. That was easy enough. And it's positive because it's in quadrant 1. Any questions on that? So we used a reciprocal identity to do that one. Okay? Now, they don't have to be that easy. You may have to do the Pythagorean theorem, which we'll deal with on another one here. Any questions on that? So it's saying if sine theta, and I should have had an equal sign, if sine theta is equal to 2/5, and we're going to be in quadrant 1, then find, there's not a D in there, then find cosecant theta. Well, that just tells us we want the cosecant of an angle in quadrant 1, so my answer is positive. Cosecant is reciprocal of sine, so we reciprocate the sine value 2/5, and we get the cosecant value 5 over 2. Okay, any questions on 3? Okay, number 4. Number 4. Number 4, we have sine theta is 1 over 4. And I'm going to leave yourself some space here. Leave some space there. Comma, theta, or 0, excuse me, is less than theta, is less than or equal to theta, which is, it just says less than theta, which is less than pi over 2, excuse me. Okay, so 0 is less than theta is less than pi over 2. That means that theta is between 0 and pi over 2. Pi over 2 is the same as 90. 0 to 90 puts us in quadrant 1. All that means is that it's in quadrant 1. They're just trying to tell us which quadrant. And in quadrant 1, they are all positive. So my final answer is going to be positive. When I get done with all my other stuff, I need to remember to make it positive. Okay? Now we're going to do all the other stuff. It asks for cosine. That's what I want to find. Now, how am I going to do that? Well, sine is what over what? That's back to that circle, those x's, y's, and r's. What is sine? Sine is y over r. You have to have that memorized. Cosine is x over r. So cosine theta is x over r, and what's my r? My r is 4. So I got that much of my answer. Cosine theta is something over 4. What something is missing? X. How am I going to get x? X squared plus y squared equal radius squared. I don't know x. X squared plus y, what was my y? 1 squared equal radius 4 squared. Is that what we're doing? We're going to do the exponents. We're going to get x squared plus 1 equals 16. Undo addition by subtraction. X squared equal 15. Undo the square with the square root. And we're talking about distance, and there's no such thing as a negative distance. And so we get x is equal to square root 15. So the cosine is x, which is square root 15, over r, which is 4. So it's square root 15 over 4. But we got to stop and think. Every time, stop and think. Is it positive or negative? Well, we've already determined that 0 to pi over 2 is quadrant 1, and they're all positive, so the answer's positive. The last thing you need to do is check your sign. What quadrant am I in? Any questions on number 4? All right, we're going to stop there for today, and we'll look at the rest of it next time, which is probably good because we're going to start doing a little bit more manipulating than we have at this point, and it'll be good to have a fresh day to go on. Appreciate your